With all the evidence that modern cosmology has accumulated over the last several decades, which includes 1. The cosmic microwave background radiation, displaying its famous axis of evil that is aligned with the Earth's equator and ecliptic. 2. The distinct distribution of galaxies, gamma rays, and quasars in concentric spheres around the Earth, which all taper off as if there is an edge to the universe. 3. The spin axes of galaxies aligned with the axis of evil. And 4. The alignment of quasars and galaxies with the North Celestial Pole. We can safely say that, as some of the best minds today in cosmology have admitted, the scientific data has put Earth back in the center of the universe.
As we look further into the geocentric universe, one important question concerns how its mechanics explain the movement of the celestial bodies, especially how the Sun is able both to revolve around the Earth and move up and down 23.5 degrees 4 times during the year to give us our seasons.
Earlier, we discovered that the reason the larger Sun can revolve around the smaller Earth is that in the geocentric system, the combined gravitational force of all the bodies in the universe both balance the Sun between the stars and the Earth and allow the Earth to be the center of mass upon which the whole universe rotates. In fact, the gravitational balance between the stars, the Sun, the planets, and the Earth is so precise that it allows the Sun to revolve around the Earth at a slightly slower pace than the stars. It is most likely the drag of the planets that slows the Sun down by about 4 minutes per day. The stars revolve in 23 hours, 56 minutes, and 4.1 seconds, whereas the Sun revolves in exactly 24 hours. Second, the universe's gravitational force that moves the Sun up and down by 23.5 degrees, or 75 million miles, over the course of a year is the same force that moves the Sun around the Earth. The Sun has 2 motions, a horizontal and a vertical, and when these are combined, they form a spiral motion. The reason the Sun has a spiral motion around the Earth is that it is following the rest of the universe that is spiraling around the Earth. The universe has 2 motions, 1, an upward motion of 75 million miles and a downward motion of 75 million miles, thus totaling 150 million miles over the course of a year. 2, it has a daily rotational motion, which moves around the Earth in 23 hours, 56 minutes, and 4.1 seconds. Additionally, the universe's rotational motion is offset by the distance between the Sun and the Earth, which is an average of 93 million miles. Hence, as it rotates, the universe shifts in its horizontal plane, and at the same time it goes up and down in its vertical plane, thus forming a spiraling motion. In the geocentric universe, the cosmic microwave radiation forms warm and cool dipoles and quadrupoles respectively, due to the fact that the Sun is the geometric center of the universe and the Earth is the dynamical center, or center of mass. The distance between the geometric center and the dynamical center is, of course, the distance between the Sun and the Earth, which averages to 93 million miles, or 1 astronomical unit. Since the large universe must pivot on the small space between the Sun and the Earth, this tiny difference will produce correspondingly small temperature differences of only a millionth of a degree in the various poles of the cosmic microwave radiation, which we see on Earth as dipoles and quadrupoles. Mechanically speaking, as the universe moves in a daily spiral motion, it creates the Coriolis force, the force that is known to turn the Foucault pendulum and move hurricanes to turn counterclockwise in the Earth's northern hemisphere and clockwise in the southern hemisphere. But the universe's Coriolis force does more than just turn hurricanes. The Coriolis force also moves the cosmic microwave radiation and thus creates the quadrupole and octopole. This is why the northern hemisphere of the cosmic microwave radiation, which is above the Earth's equator, is oriented with its poles on either side of the ecliptic. Essentially, the universe's Coriolis force creates distinct eddies of microwave current, similar to how the Coriolis force creates eddies of water and air on Earth. In the end, our picture of where we are in the universe is quite simple. This image is from the 2001 Wilkinson Microwave Anisotropy Probe's view of the whole observable universe. As we have seen, all the data show that we are at the very center. Of course, the only question left is, who put us there? Only fools would conclude that such a privileged position could happen by chance.
Since ancient times, the world, our universe, has been understood as geocentric. Even Stonehenge, estimated to be more than 5,000 years old, turns out to be an ancient astronomical observatory built on the geocentric system with the rest of the universe, rotating on a tilted plane of 23.5 degrees.
Modern science, with its extensive studies of the cosmic microwave radiation and the discovery that is oriented around the Sun-Earth ecliptic, has in a very profound way joined modern cosmological observations to those of the ancient world. At one end of the historical vision, Stonehenge tells us the same story that the cosmic microwave radiation tells us. The whole universe operates and is aligned on the distance between the Sun and the Earth. The only system that incorporates these two endpoints of historical discovery is the neo-Tychonic model of geocentrism, which shows how the small space between the Sun and the Earth, and the equator and the ecliptic, allows for a motionless Earth in the center of the universe with all of the other celestial bodies moving around it.